Welcome to this video. In this video, we are going to be talking about large language model powered coding assistants. Before we look at the agenda slide, let's just take a moment to consider the broader impact of generative AI on software development. First and foremost, it is clear that generative AI is going to be a groundbreaking technology. In fact, there are already real-world applications where it is making a difference, and I'll go over some of the case studies later on in this video. Second, generative AI is not just impacting the coding aspect of the software development lifecycle. It is impacting initial strategy, design, coding, documentation, and enhancing the overall productivity across the lifecycle. Developers are encouraged to engage with these AI-based coding tools, understand the strengths and weaknesses, and equally importantly, understand how their own experience in building software can augment the code that is being generated by this AI-based coding assistants. There's no question that generative AI is going to have an impact on the team bandwidth. Could they take on more work without increasing the headcount? Could they take on projects that have been on the backlog for a long period of time? And then finally, we want to talk about the broader impact. What does the future look like? How will it change the supply and demand for software engineers? How would it impact the software estimation models? Could it potentially lower the cost of building and maintaining software? Let us take a look at the agenda that we are going to follow for this video. I'll start out by sharing some of the experiments that I've conducted related to machine learning applied to software engineering. We'll quickly transition into looking at some research out there that talks about the productivity benefits of large language model powered coding assistants. And then we'll make all of this conversation real by taking a look at a reference application, starting out with requirements, building out the architectural foundation, getting into some design patterns, developing some subsystems generating code, and then ultimately doing some testing and provisioning cloud resources. And we'll end this session by talking about some of the key takeaways for you as developers and how you can leverage generative AI. As I mentioned earlier, I've been tinkering with this idea of how machine learning can make me a better developer. And this video that I recorded in 2015 at an Azure conference was really designed to bring out some of the techniques. Let me go over to the video here for a second. And as you can see here, one of the examples that I had included as part of this video was I have a legacy routine, perhaps a mainframe routine written in COBOL. There's no documentation, and in some cases, the source code is not available as well. How can I train a neural network to reverse engineer the logic behind these routines? So these are some of the ideas, worked in some cases, not quite reliable. This led me to think about deep neural networks as an important building block that we as developers needed to understand. And some people have called deep neural networks as software 2.0. This also led me to work on a paper with Ankit, where we looked at a small language model. And this paper was written in 2021 and 2022. And the idea here was that if you look at these large language models, they do a good job of translating from one language to another. But given the scarcity of open source code that is available for COBOL, it was really hard to train a language model with large repositories of COBOL code. So we focused on this idea of, can we work on a small language model, which could take perhaps 1 million lines of COBOL code that was available to us, and try to make sense of this code. So allow me to go to the paper here for a second. And I want to point out to a diagram right here. So here's the paper. You can read this paper in its entirety. But you can see the diagram right here on this paper. What we did was we took these lines of COBOL code, 1 million lines of COBOL code, and then tried to create embeddings for these code and then plotted them in the diagram that you see in the screen here. And that's telling you the kinds of code patterns that exist in that 1 million lines of code. And when you're looking to modernize an application like this, what you look for, and the things that are most expensive typically, are the outliers, which are really hard to migrate to an environment like a cloud environment. Now fast forward to March of 2023, and you begin to see messages like the one shown here on the screen. So here, Morton is talking about how he used GPT-4 to build an iOS application from scratch. Of course, this is a simple application to help you pick a movie. But despite that, all of the code and all of the graphics were generated using GPT-4. And in some ways, messages like this led me to think about how I can use GPT-4 not just to build apps like the one you see here on the screen, but how can GPT-4 help me become a better developer and help solve the business problems that we face in the enterprise. So with that said, let us turn our attention towards how we can use coding assistance in everyday problems that we solve as professional software developers. And let me also bring out a book that has helped me think about this topic. This is a book from Manning by Nathan Crocker. And this book has given me some ideas that I've incorporated in this video as well. So I recommend you get a copy of this book if you're interested in this. Let us begin by looking at the different tools that are available to us. Of course, you have the ChatGPT, you also have the GitHub Copilot, and you have the AWS Code Whisperer. Now, these tools have different engagement models. ChatGPT, of course, is a website where you log in, enter a prompt. The prompt could be coding related, and it gives you a response back. The GitHub Copilot and Code Whisperer are tools that are integrated into your development environment. Now, we also have the Copilot X, which is a recent release. It merges the capability of coding assistance with a chat-like interface, and we'll be looking at Copilot X later on in this video. The idea here is to promote a distraction-free coding environment, which means you don't have to context switch between your IDE and a chat environment. As far as the code presentation and generation is concerned, ChatGPT can generate code at different structures, can be at a block level, method level, class level, or even a higher level. With Copilot and Code Whisperer, you are building code in a sequence, evolving to handle larger segments of code. Let us also compare the interaction model. In case of ChatGPT, your interaction is solely prompt-driven. With Copilot and Code Whisperer, you have the benefit of specific prompts, but you're not limited to the prompts. It can also provide you autocomplete suggestions. So in summary, ChatGPT can be ideal for exploration, for prototyping, when Copilot and Code Whisperer are best for focused coding with clear goals and tight deadlines. Now that we have seen tools like GitHub Copilot and AWS Code Whisperer, let us take a look at a sampling of research that talks about evidence around developer productivity benefits from AI tools. The first study comes from Microsoft Research and GitHub. In this study, they examined the productivity impact of AI tools. Specifically, they set up an experiment where GitHub Copilot was treated as an AI pair programmer. The experiment was a controlled experiment where programmers were asked to develop an HTTP server in JavaScript. Two groups were compared. The treated group had access to GitHub Copilot. The control group had no Copilot access. And if you look at the results, the treated group was about 55.8% faster than the control group with a higher confidence level. If you look at the key beneficiaries from the study, programmers who had less programming experience, or programmers who may have had a larger experience but less experience with JavaScript, and programmers with more daily coding hours seem to benefit the most. So the implication of this study is that AI as a pair programmer, GitHub Copilot as a copilot or a pair programmer, shows promise in enhancing software development efficiency and accessibility. Let us look at another study, and the source of the study is mentioned at the bottom of the slide. The authors of this study wanted to look at how good is ChatGPT as a programming assistant. And what they did was they used problems from a lead code dataset, and I'll show that to you in a second. And then they looked at the problems, easy, medium, and hard, and saw how ChatGPT did with these kinds of problems. Let me show you an example of an easy problem from the Lead Code 2022 dataset. Once again, the source is mentioned at the bottom of the slide. This is an easy problem. You're given an integer and you're required to return its complement. Let's take a look at a harder problem. Here, the goal is to return the median array for each window in the original array. And answers within a certain range of the accepted value are deemed correct. And if I go back to the previous slide, you can see here that ChatGPT seemed to do quite well as compared to other models. It did quite well with the easy problems, but as it gets into medium and harder problems, it is clear that it is harder to generalize the solutions. Now, I should add that once they started providing it hints, and they were trying to ask it how it can correct some of those mistakes, it seemed to do better. Another important aspect of AI-based code assistance is code summarization. And here is a chart that's very interesting. And this chart is showing you similarity between code interpretation by the AI-based model and the problem description. And if you look at the center of the diagram, the white boxes represent code that was accurately generated by our AI code assistant. The black boxes represent code that had some inaccuracy in it. And what is interesting to see is whether the code was correct or had some inaccuracy in it. The similarity between the code intention and the problem description is fairly similar. And this brings us to an important observation, which is code summarization is going to be an important benefit of AI-based code assistance. And as you can imagine, there are lots and lots of legacy code still around. I mentioned this earlier. If we have this ability to give it a piece of code and have it explain that code, that greatly improves our ability to modernize legacy code. So we have talked about code generation and even code summarization. Can AI-based code assistance help with code repair? And that was the focus of the study conducted in the paper mentioned at the bottom of the slide. We've all dealt with large number of warnings typically associated with quality. Wouldn't it be nice if AI-based code assistance can help us fix some of these warnings automatically? What you see in the center of the screen is a snippet of Python code that has a quality warning associated with that. And of course, the fix is to add the try and catch blocks. In fact, the papers of this study have created a pipeline, they call it the core pipeline, which puts in process a system to fix quality associated warnings. And if you look at this diagram from left to right, first is to take the output of the static analysis tools. Then you look at the quality issues that were flagged as part of the static analysis. Then you generate a candidate set of recommendations that can repair these warnings. Then you prune the revisions that are still flagged, and then you potentially accept the versions that may address the quality warnings. Another important aspect of AI-based code assistance comes in the form of code translation, ability to go from one software language to another. Once again, look at the bottom of the slide for the source of the paper. The authors of the paper conducted an experiment where they converted a set of languages, the source language column shown on the table, and converted it into a series of target languages. And they also depict the error rates associated with this translation. And they found that the incorrect translations ranged from 52.7% to even 97% in certain studies, depending on the LLM model that was used and depending on the source to target language. And they also came up with some of the reasons why these translations were inaccurate. And let me just show you an example. So if you're going to the Go language as the target language, the first example shows you that if you have unused import statements that are not permitted in the Go language, so that might result in one translation error or warning. And similarly, you can see another example from going from Java to Go, and the same code, when translated, returns an incorrect piece of code. It turns out that there are ways to improve code translation, and one of the techniques to do that is known as prompt crafting. Let's take a quick look at that. And the idea here is that you provide the language model with an opportunity to go correct the code. So we start out by saying, this is what you were told to translate. Your response generated this error. Can you regenerate the response, taking into account the error that was returned as part of the translated code? The notion of prompt crafting that we talked about in the previous slide brings us to the second important takeaway from this presentation, which is the need for asking clarifying questions. So if you look at the center of this diagram, if you as a developer come in and ask the language model to create a function, in this case, generate a Fibonacci number, it is going to generate some code, and it is now your job to come in and ask questions, clarifying questions. In this case, the clarifying question could be, would this function be able to handle negative values? Should it return an error? Will it raise an exception? Will it handle negative inputs in a specific way? If you ask these kinds of questions, chances are that the language model will have an opportunity to improve the generated code. Let us now take some of the ideas that we talked about in the previous slide and put them into action. What we are going to do is we are going to go over to the OpenAI playground. And let's take a look at an application here. So we are inside the OpenAI playground. And I'm going to be using the latest GPT-4 Turbo model. And later on in this presentation, we will transition into the GitHub Copilot. But let's start out with just talking to GPT-4 and trying to get some code assistance directly from GPT-4. What you see here on the screen, we have a bunch of system requirements. We are building a system that many of you are already familiar with. It's an IT asset management application. So we have things like asset inventory, maintain a comprehensive inventory of all of the IT assets. We want to be able to track these assets. We want to be able to support the full lifecycle management of these assets. So we are asking the model to understand our system requirements and wait for us to ask additional questions. And that's what it does exactly. The next thing we are going to do is we're going to say, now that you understand the high-level system requirements, can you come up with a mermaid diagram? And mermaid diagram you will see shortly. It's a great way to generate these diagrams. GPT-4 is not going to generate the diagrams for us per se. It is going to give us the code associated with the mermaid diagram. So the first thing we're going to ask it to do is give us a high-level, subsystem-level diagram for the IT assets management application, and we just gave you the requirements. We are also going to take one of the subsystems. In this case, let's just take the asset inventory subsystem, and we are going to also ask it to create some of the classes associated with the asset inventory. So if I ran this code right here, I'm going to get some mermaid syntax, which you can see on the screen. I can go ahead and cut and paste this syntax into a mermaid live editor. So let me go ahead and do that in order to save us some time. I already ran this prompts, and I already have the mermaid editor open here. So essentially what I've done is I've taken the output that was produced by ChatGPT on the screen here and pasted into a live online mermaid diagram editor. So if I pasted the diagram on the left, you can see it gave us a high-level view of the various subsystems that we need to have in place in order to implement the IT assets management application. Similarly, if we go to the second part of the request we made, we also asked it to look at the asset inventory and give us a class diagram for classes associated with the asset inventory. And if you take this mermaid diagram and paste it into the live editor like we did the last time, and once again on the left is the code that was generated by GPT-4, and on the right is the view, a diagrammatic view of the code on the left. And you can see here it came up with some classes. It thinks that I should have an asset class with a bunch of attributes. It thinks I should have an employee in a department class. And then because we want to track asset inventory and asset life cycle, it also came up with an asset history class. Now that we have seen a high-level view of different subsystems that go into an IT asset management system, we also have a notional class structure for the asset inventory. It's time to progress our conversation further. We're going to ask GPT-4, how would it model hardware versus software assets? And it goes ahead and suggests that maybe you can have a parent class called asset, and then you can derive hardware and software asset classes from that. And that makes sense. It also gives us the mermaid diagram, and I'm going to skip showing you the mermaid diagram because we just talked about how you can paste this code inside a live editor. Let's continue the conversation forward. We also need to be able to handle depreciation, and we know that depreciation is going to be different for hardware versus software assets. We also need to be able to calculate aggregated depreciation for the department. So a department can have one or more assets assigned to it, and each department wants to calculate the depreciation. So it goes ahead and comes up with a clever strategy. It knows that depreciation may be different for hardware and software. So it comes up with an interface called iDepreciation strategy. And then you can implement a concrete version of that in the form of hardware and software depreciation strategy. That makes sense. But this is a point where our knowledge of design patterns can come in handy. And this is another important takeaway from this talk, that the more we know about design patterns, the better we are able to guide the model. So in this case, I came in and asked this question: wouldn't it be better to use a visitor pattern if you're going to be able to calculate aggregated depreciation for all the departments? Wouldn't it make sense? It goes ahead and replies that yes, visitor pattern would make sense. And then it even comes up with an implementation of the visitor pattern. So if you're familiar with the visitor pattern, the idea here is that you have an interface called iAssetVisitor, which has a visit method. And then the corresponding class like asset would have a method called accept, which will accept the visitor pattern. And in this case, once it has accepted it, it can then call the visit method repeatedly to calculate aggregated depreciation. Now that we have begun to see how we can construct the domain model for our asset management application, it is time to look at some of the concrete implementation aspects of our IT asset management application. So we're going to ask the model to come up with a REST API architecture. We have heard a lot about the hexagonal architectural pattern, and we want to ask the GPT-4 model if the hexagonal architectural pattern would be a good fit. At this point, GPT-4 goes in and says that hexagonal architectural pattern would be a good fit. It outlines some of the advantages in terms of integration, flexibility, testability. So that makes sense. The next thing we are going to do is we're going to ask it to generate a diagram of how it would implement the hexagonal architectural pattern. So once again, it goes ahead and creates a mermaid diagram, and I'll show you this diagram in a second. But at a high level, it has implemented the core tenets of the hexagonal architecture. It has come up with an asset inventory service. It has come up with a repository interface. It has come up with adapters, which is a way to communicate with the outside world, whether it is the database or the UI. And it has proposed a high-level view of the asset controller as well, which will be the key underpinning for our REST API. Let's go over to the Mermaid editor and see this diagram in action. Once again, we are inside the Mermaid Live Editor, and I have pasted on the left-hand side of the screen the Mermaid diagram text that was generated by GPT-4. And on the right-hand side of the screen, you can see the diagrammatic view of this code. So if you can see here, we have the asset controller, we have the asset inventory service, we have the asset repository, and there's the notion of the ports and adapters, how you interface with outside applications. And then, of course, it brought in the domain model, classes like the asset class. And then, of course, you have the repository pattern implemented here as well. Let's go back and continue our conversation with GPT-4. So now we understand how the hexagonal pattern would be implemented, but I am an ASP.NET developer and I want GPT-4 to take the concepts that it has created for me in terms of the hexagonal architecture and map them into constructs that I know about when I'm implementing an ASP.NET Core Web API. So at this point, GPT-4 is going to take the diagram that it generated previously, and it is going to annotate on that diagram mappings to the ASP.NET Core Web API project. Once again, here's the diagram, and I'm going to show you the equivalent mermaid view in a second. We are back inside the live editor, and what you see here on the screen is the diagram that was generated previously. So this diagram is showing us the elements of the hexagonal architecture. If I go into the second mermaid editor here, and here I've pasted the diagram that was annotated with mappings to the ASP.NET Core architectural elements. So here you can see our asset controller maps to the controller in ASP.NET Web API project. Similarly, the asset inventory maps to the service concept. Similarly, you have the data transfer objects that are available to you right here. So it has done a good job of trying to map the hexagonal pattern that we were interested in implementing to core concepts with a project type that we are already familiar with. Let us start a new conversation with GPT-4. And we are going to move away from the logical aspects of the design to physical aspects, which means we are going to start talking about the Azure services that we are going to need to host our application. Since this is a new conversation and these models are stateless, I have to provide it the background information about the application we are building. And the next thing I'm going to do is ask it to generate a mermaid diagram that presents us a candidate set of Azure services that are likely going to be needed to implement an application like this. Once again, it has generated a mermaid diagram, and we are going to paste this diagram into the live editor. Let's just go ahead and do that. So I'm going to go into the live editor. On the left-hand side is the text that was generated by GPT-4. And let's look at the diagram on the right. At the center of the diagram is the ASP.NET Core Web App. This is where our web application is going to be hosted. Of course, it included the notion of identity management. It also has the front-end user interface and the mobile app, should we need it. If you look at the left of the diagram, assuming we want to monitor and manage this application, it included a notion of Azure Monitor. Assuming we want to integrate our asset management application to external systems, it included the notion of Azure Logic Apps, as well as the notion of Azure Event Grid. It also included a notion of Power BI service, should we want to visualize the assets that are stored in our inventory. And then finally, in terms of data storage, it included Azure SQL Database as the primary database for storing information about the assets. It also included blob storage. Perhaps we want to store pictures and videos of assets. And then also included a notion of Azure Cosmos DB. Let us continue our conversation forward. We like the candidate set of services that were generated for us. But we have another important requirement. We want to make sure that any traffic that is routed between Azure SQL Database and Azure Web App does not go over the internet. It goes over a private connection. So we're going to come back and ask GPT-4 to update the diagram so that all of these services are based on virtual network. And it is going to go ahead and create us a diagram. Let's just go over to the live editor and take a look. Once again, on the left is the code that GPT-4 generated. And if you look at the diagrammatic equivalent of that code, you can see here that it has gone ahead and updated the diagram. And it has included the VNet integration capabilities. So the web app is VNet integrated. Furthermore, if you look at Azure SQL Database, it is now taking advantage of a private endpoint. Let's just go back to our conversation. So we have already now created a VNet-based architecture. Let's just go further and continue our conversation. What is interesting is the first time it gave me a diagram that had an error as far as the Mermaid syntax was concerned, and I'm not very familiar with the Mermaid syntax, so I had to go back and say that there's something wrong with this code you generated, and then it fixed that diagram. So the diagram that I just showed you a moment ago was the updated diagram. At this point, I want to continue the conversation forward and ask it about what is the scale unit? How am I going to scale this application if I'm going to see a sudden burst of load? And it goes ahead and talks about the different scale units as part of the architecture, whether the scale unit is an app service, an Azure function, or an Azure SQL database. The next thing I want to ask about is the overall SLA. So it has proposed us a candidate set of services. These services have different SLA, and we are asking it to come up with an aggregated SLA. So if you know this already, you'll appreciate that SLA is typically a multiplication. So if I have two services that have an SLA of 99.9, I'll end up with a composite SLA of 99.8. So it's slightly lower. It went ahead and calculated. Now keep in mind, its knowledge cutoff for GPT-4 Turbo is April of 2023. So you have to be very careful about that because these things tend to change a lot. But assuming the information from April of 2023, it went ahead and calculated the SLAs for each individual service, and then went ahead and calculated the composite SLA for us here as well. Now that we have an understanding of the composite SLA, we realize that maybe we do indeed want a regional failover built into our architecture because we are not quite happy with the composite SLA that we got. So we go back to GPT-4 and say, hey, help us implement a regional failover. And then we provide it with an additional condition. We want the regional failover to be active-passive. So we want the storage to be replicated, of course. But we don't want all of the web app and Azure functions and logic apps to be replicated. If there's a failure in the primary region, we would run a script or some sort of an automation job and stand up those services. So it went ahead and created a mermaid diagram. Let me just walk you through this diagram right here. And here you can see it created the primary region for us. Rest of the diagram remains the same. It created a secondary region, and because of the active-passive nature that I described just a moment ago, it only is actively replicating the data storage portions of our architecture into the secondary region. At this point, we are back into our conversation. We go ahead and talk about regional failovers, but we also want to know which region should we be deploying. So we say that our users are in Virginia, United States. Which regions should I be deploying? And once again, based on its knowledge of the documentation, which is current as of April 2023, it comes up with suggestions for what primary regions that you want to use. I can keep going further. The next thing I can do here is, maybe I don't want to take advantage of regional failover. I want to take advantage of a zonal failover, which is another important construct in Azure, and I can have it update the diagram based on a zone-based failover. And once again, it goes ahead and creates us a diagram. So this brings us to the end of this conversation, but it brings us to another important takeaway. If you're going to take advantage of coding assistance like the one we have been looking at, it will be very helpful to have a broad understanding of Azure services. So this idea of regional failover, the idea of VNet-based connectivity, this idea of zonal failover, if you had an understanding of these services, you'll be able to ask clarifying questions so these coding assistants can help you generate architecture that matches your requirements. I'm inside Visual Studio Code, and now that we have a high-level architectural view of our application, it is time to now focus on filling out these classes, and this is why we are going to be inside GitHub Copilot and GitHub Copilot Chat. The first thing we are going to do is we're going to see which extensions are installed as part of this Visual Studio Code. So I'm going to hit Control-Shift-P. Let's look at the extensions. Let's look at the Git related extensions. Looks like we have the Copilot and the Copilot Chat already installed. That's great. Let's just go into the files. And what I've done is, in order to save us some time, I have created an empty ASP.NET Core Web API project. And here I have folders like controller. And if I look into the asset controller.cs class, right now it is blank. And similarly, I have the asset.cs file created, but it is also blank. And what we are going to do over the next several minutes is use the inline chat to populate these classes. So let's go ahead and get started. My favorite shortcut is Control-Shift-I. That brings up the inline chat. So let's just go ahead and do that next. And once the chat comes up, there it is. I'm going to paste the first prompt. Let's take a look at the prompt. Here, it starts out with workspace. We are telling it to look at the entire workspace, not just the file that is open, which is asset.cs. Define an asset class in a certain namespace. We want to make sure that it uses the nullable reference types so that these properties are appropriately initialized. We are providing it a list of properties that are part of the asset class. So at this point, we are ready to go ahead and run this prompt. And once this prompt is complete, you will see that it starts generating some code. And then what we are going to do is copy that code into the asset.cs class. So I'll wait for it to complete giving us the code. Looks like that's complete. Let's just go ahead and paste it inside asset.cs class. And here you can see the squiggly lines here because the funding details class is not defined. That's okay. Let's just go ahead and create the hardware.cs class. And once again, I'm going to hit Control-Shift-I. And what we're going to do is we are going to provide it a prompt to produce the hardware class. So let's just go ahead and paste the prompt up at the top like we did the last time. And here we're going to once again start with workspace. So make sure you look at the asset class that was already defined. Create a hardware class that inherits from the asset class. So asset class is the base class. We're also providing it with a bunch of properties like we did with the asset class. And we are also saying that make sure that you use the nullable reference types so we don't run into things like underposting, which can be a problem later on as we develop the controller. So you can provide additional instructions. Let's just go ahead and run it. At this point, it will start generating the code. And notice that it also referenced the asset.cs class. So not only is it generating the code, it is telling us that it used another file as a reference. Let's just go ahead and copy the code. And we're going to go ahead and paste it inside hardware.cs class. We're going to do the same thing for funding details class. I'm going to paste the prompt, very similar to what we have been doing up until now. And let's just go ahead and create the code. And once the code is created, I'm going to once again copy and paste this code into the funding details.cs class. So I'm going to accelerate through this a little bit since you've seen these steps. So now that we have done the funding details.cs class, let's also do the depreciation strategy. Let's go inside the depreciation strategy. Let's just once again paste a prompt. And I want you to note one thing here. Of course, we start out with the workspace. Here we are providing very detailed instructions about how we wanted to create different types of depreciation. And if you can look here in straight line value, you have the declining and then you have the double declining. And it's very hard to complete this just by an autocomplete, and you have to provide these details. Let's just go ahead and generate the code. And once the code is generated, we are going to copy the code and we are going to place it inside depreciation.cs class. At this point, we would have completed all the domain classes. And once again, I can see an error. We'll come and deal with this later on. Let's just go ahead and look at the asset factory next. So let's just expand on the factory tab there. And let's just go find code for the asset factory. Let's just go into the inline chat. Let's paste a prompt. And I'll walk you through that prompt. And here we are creating an asset factory. Here again, we are providing additional details about if the asset is of type hardware, we want it to call the hardware asset factory method. And all the details are provided here. And this is why I like the inline chat, because I can provide free-form instructions. And once I'm done providing these instructions, I can go ahead and run this prompt. And I'm going to make all of these prompts available. Towards the end of the video, you will see a GitHub link with all of these prompts, so you can explore these on your own. Looks like our code was indeed generated. Let's just go ahead and copy and paste it inside the asset factory class. At this point, we are still left with the controller. Remember, we don't have any controllers yet. So let's just go ahead into asset controller. Right now it's blank. Once again, bring the inline chat with Control-Shift-I and then paste the prompt. And let's just go ahead and paste the prompt. And this is much simpler. It knows that there is a factory. It knows the domain objects. Let's just go ahead and create a controller. And we are just going to use the put verb. So you can see the HTTP post action has been created. And notice here that we are referencing a number of different classes here as part of that. So the model is not only generating the code, it is citing all the references where it based the code from. Let's just go ahead and paste this here. And at this point, we should be able to save all the files. So I'm going to hit Control-K and followed by an S. That saves all the files. Let's just go ahead and build our project. And we're likely to see some error messages because we had some squiggly lines. Let's just go ahead and run .NET build, and looks like we have 3 errors. Let's just go look at these errors one by one. And let's just try to fix them. So the first error here is that this seems to be a type mismatch. We are calling a math.pow or math.power function. It requires 2 doubles, but I think we are passing a double and a decimal. Let's just see if Copilot can actually explain what's going on here. So here the Copilot sent that instruction. So I didn't have to write the prompt. It was automatically created for me. I just had to hit explain and the prompt was generated for me. And it is explaining to me that it is indeed a type mismatch problem and I would need to do an explicit cast. In fact, provided the code for me right there. Let's just copy and paste that code and replace it with the line that was causing that error. Let's just fix the formatting. Let's tab over, make sure return aligns with the rest of the code. So that's one error already fixed. Let's just go take a look at the other problems we are having here. I think the other problem pertains to the asset factory. And you can see those 2 lines there. And turns out that the depreciation rate is really not part of hardware. In fact, if you look at the hardware, it derives from asset. And if you look at the asset class, inside the asset class, there's a funding details class. And if you look inside the funding details, that's where those properties are defined. So it got it wrong. So there is a very simple fix. What we are going to do is create a funding details class, set those properties. Let's just save, compile, and run. And this time it not only ran, it gave us a URL. Let's just go ahead and copy the URL. Let's go back to the browser. Let's paste the URL and add swagger/index.html. This should return the one controller that we have defined, the post method. Let's go ahead and try it out. So we're going to define an asset of type hardware. Let's say it's a keyboard. Let's say the value is $50 and the useful life is 2 years and no depreciation strategy. Let's put a dummy number for the depreciation rate. Let's say that the salvage value is $5 and then let's say it was purchased on 1/1/2023. Let's just go ahead and execute. At this point, if we did everything correctly, including building the controller, we should return a 200, which we get. This means our asset was indeed added into our asset system. So this concludes this demonstration of using GitHub Copilot with Chat. Now that we have a version of our asset controller working, what if somebody came to us and gave us a new requirement? It turns out that these assets are getting added to our inventory at a very rapid clip. And we want to be able to send out messages whenever a new asset gets added. We don't have a provision for that in our current code base. How can we use a coding assistant to help us extend our application to include a messaging or an eventing capability? Now, I could have done this example directly inside Visual Studio Code, and I could have gone to the GitHub Copilot Chat and asked it to make some suggestions. Instead, I want to show you an example of doing the same thing directly inside the playground. I don't have the at workspace argument that we have been using in the prompts previously, which gave us access to all the files in the workspace. So I had to resort to a small trick. I wrote a script which opened all the files in my solution, copied all of the .cs files into one large text file, and that's the file I'm going to provide as a context into my prompt. So if you look at the prompt, our first instruction is for the model to go line by line through the code and wait for questions to be asked. And at this point, in order to make it easy for us to search this long script, let's just go ahead and search for a word observability. And here's the prompt that I've constructed. We need to improve the observability of the system. We need to figure out when the assets are getting added. Every time an asset is added, we want a message to be sent to the Azure Service Bus. Can you help us figure out where this code needs to be added? And as you can see, the model comes back with some instructions. You will need to incorporate these NuGet packages. And then it also, in fact, comes up with some code where this code can be added to a service class or whatever class is appropriate based on the current code base. So here's an example of how you can extend the current code base using a language model. Let us go beyond development and let's look at testing aspects. Here I'm creating a prompt, and my goal here is to create unit tests that can help us test declining balance depreciation strategy. And of course, since we are looking at the workspace, it knows about the definition of the class right here, and it is able to then generate unit tests that can help us achieve our testing objectives. If I go further down, let's go beyond the unit tests, and this time let us create a prompt asking the language model to generate a behavior-driven development script that will allow us to add 2 assets to the asset factory, and then it has to confirm that all asset costs at least $4,000, something like that. And it is able to then help us run this BDD script. It gives us some tips about how to set up the environment. And then here it begins to define those behavior-driven tests right here. And if I go further down, it also provides an implementation for these steps in the form of asset creation steps.cs. And as you can see, these are the steps that were included in the behavior test described above. With this, we come to the final aspect of our rather long demonstration. It is time now to deploy our code to appropriate Azure services. And here's the prompt. I'm asking the language model to generate a bicep template based on the context. And context, once again, is all of the code that I have provided it, as mentioned in the previous clip. In addition to asking it to generate a bicep template, I'm also providing it a hint that since this is just a demo, I want it to use the cheapest possible Azure resources, the cheapest possible plan for Linux, and also I don't want it to include the Docker definitions. Once again, it goes ahead and starts generating the bicep template, and as you can see here, it comes up with some parameters. It also ends up using the free plan, size F1, family F. And I didn't know what constitutes the cheapest plan, but it figured that out for me. And it generated that script for me without the Docker definitions. Before we close the video, I wanted to talk about a tool that was just announced at Ignite last week, which is the Microsoft Copilot for Azure. And that has relevance to the discussion that we are having. Much in the same way, we have the GitHub Copilot. As we have seen, AI companion for software developers. You have Microsoft Copilot for Azure that can help you configure and set up Azure services. So for example, if you wanted to answer questions, author complex commands, you're authoring complex KQL queries, Microsoft Copilot for Azure can help you. If you're troubleshooting certain services, you're trying to identify root causes or come up with suggestions, that's where Microsoft Copilot for Azure can help. And finally, it can help with optimization of resources, helping you improve scalability and reliability of your applications. Right now, I don't have access to the Microsoft Copilot for Azure. It's in preview right now. So I'm going to show you a few screenshots from a presentation from Ignite last week. So here's an example of a resource graph explorer. And if you wanted to come in and let's say look at, show me all the virtual machines that got created in the last 5 hours. It will convert that command into the Custo query that's shown at the bottom of the screen. Here's another example. If you wanted to look at the cost, you can come in and look at the cost and compare it to the cost from the previous month. And once again, this would require a lot of analysis or writing commands, and all that can be done using the Azure Copilot. Let's look at another example. Once again, we are in the Azure Resource Graph Explorer, and we are trying to figure out what is the memory usage for a certain virtual machine. Again, you could have done that yourself through the UI or by writing queries yourself, but much easier to do this using simple English syntax. And the final example right here, steps that you can take in order to create an app service. How can you monitor an app service? What are the best practices? And how can you secure Azure Cosmos DB? So with that, we come to the end of this video, and I'm going to have this final slide to sort of bring back to the original point that we started with. How can large language models help us become better developers? It's certainly not going to make us obsolete, but it is really important that we learn about large language models because it is going to give us a significant advantage. With this slide, we come to the end of this video. Before I close, I wanted to summarize the key takeaways that we collected throughout the course of this video. First and foremost, wanted to emphasize the importance of code summarization. As we discussed earlier, code summarizations can be quite effective even when the generated code is not 100% accurate. This means that large language models' ability to explain complex code is going to continue to be very important. Number two, our experience in understanding the edge cases, being able to ask clarifying questions, our understanding of design patterns is going to ensure that the code generated by large language models is of higher quality. The third point, we need to continue to understand the broad ecosystem of Azure services. We have to concentrate on applicability of these services, how they fit together. And as we have seen earlier, AI tools, large language models can help us simplify the understanding and the need to understand and remember the syntax. Next, we need to be proactive about identifying and addressing potential inaccuracies. And this goes to the point that I mentioned in the previous slide. By being vigilant about the generated code, by asking clarifying questions, we can be proactive about identifying and addressing potential inaccuracies. And then finally, we have to continue to become more proficient with the tools. I showed you the GitHub Copilot, the GitHub Chat. We also briefly talked about the Copilot for Azure. These tools can continue to improve how we build applications and help us achieve the potential of these services. With this, we come to the end of this video. Before I close, let me reiterate a theme that has been consistent throughout this entire video. Generative AI won't make Azure developers obsolete. However, those developers who harness generative AI tools will gain a significant advantage over those who don't. Thank you for watching.